Thanks very much. So why? Why didn't we all come with an electric car to the Ecosummit? And why are we looking for a power cable all the time? That's, of course, because of the energy density of batteries. So in the next 5 minutes, I'd like to explain to you how we boost the energy density of lithium-ion batteries with our pure silicon anodes, and also how this boils down to an investment opportunity. So this is how a battery looks like, a lithium-ion battery, and it's used in a wide range of applications, be it in consumer electronics, in health tech, will be applied in drones, but also, of course, in electric vehicles and in energy storage. And it consists of an anode sheet, of electrolyte, of a cathode, and a separator. And we believe that lithium-ion technology is really here to stay for the next 20 years. And why is that the case? Because it's dominant. People are, or companies are investing heavily into production capacity. It's widely used in a range of products, so there are economies of scale, and the energy density can be improved. The problem, however, is in the silicon. I'm going a little bit too rapid. Sorry. So the problem with the energy density of lithium-ion batteries is in the anode. It has a graphite anode, and the capacity is reached, the theoretical capacity. And the whole industry is looking for a better material, which is silicon, and that has a 10-fold capacity over graphite, so it's great. But the problem is, when you use it as a battery material, it cracks. So this is where we found a solution. We create pure silicon anodes that are porous. So they both have proven a 10-fold capacity over graphite, and they are mechanically stable because the swelling of the silicon is absorbed in the porous structure via nanotechnology. So it has a 10-fold capacity over graphite, and what does that mean? It means that we can increase the energy density with 50%. And currently, the industry is realizing an increase in energy density of 3% per year. So what does this mean in economic terms? The lithium-ion market is huge. The growth is driven by electric vehicles, of course, but there are a whole other range of applications, such as drones, that will fuel the growth of lithium-ion as well. And, as a part of that, the anodes roughly take into account 20% of that. So that's our addressable market. Of course, we cannot immediately address that whole market. That depends on applications. We will start out with our pure anode in applications that don't require that much cycles, which is consumer electronics, 300 to 500 cycles. And then we have to prove that with our method, we can industrialize. And we think we can do that. We think we can reach cost parity with the existing coating process, which is fast, but can never reach the energy density. And we do it on machines that are currently used in the semiconductor and in the PV industry. So there are already suppliers there. The only thing we need to do together with them is to increase the speed of those machines. So not so much slow and accurate, but much faster. Sorry, struggling a little bit with the... So we are a spin-out venture from ECN, Dutch Energy Research Center, and we were incorporated in April last year. We raised 625K seed money in September, and we already reached 3 out of 4 technical milestones. The last thing that we're going to do right now, before summer, is to prove our technology in full cells, pouch cells, which is the most difficult format to prove in. After that, we'd like to raise money, I'll explain it a little bit more, to get to a base plant where we can demonstrate that we can indeed produce these anode layers much faster at a more economic level, and also to supply OEMs and battery manufacturers with test material. That's sort of our minimal viable product, and we can make a nice earning out of that. And then our strategy is not to become too much capital intensive, because you know how costly these gigafactories are. We're going to license out our technology to battery manufacturers and OEMs. So that's a nice story. Can we actually deliver? We have a very solid and seasoned team. with people coming from the lithium-ion industry, very well connected, with a lot of practical R&D experience, but also with great networks. And we work with some of the leading German battery institutes. ZSW is, I think, the leading battery institute in Europe. And the University of Münster is also very well known in electrolyte. So, investment opportunity. So currently we're funded with 625K. We can last until Q1 next year. But we would like to raise 5 million after summer, after we've proven our pouch cell, to get to our base plant. And probably part of the 5 million will not be in equity, it will be in soft loans or in subsidies. That's it. Thank you for your attention.